So, hi everybody and welcome to this presentation called Java 10, Bridging the Gap Between Database and Stream. And even though the title says Java 9, it doesn't, it says Java 10. You can run this with Java 8 or Java 9. My name is Per and I'm CTO of Speedment from Silicon Valley. And most of the examples I'm going to show here today springs from this article I wrote in Oracle Java magazine last summer about using streams instead of SQL. So, every time you mix languages such as Java and SQL, you're going to get bugs because the languages, they work in fundamentally different ways. So wouldn't it be nice to be able to use Java as you all like and use the things like streams and predicates and functions instead of using SQL? There are a lot of hurdles, as you can see on the left-hand side. So why not clear the stream and go with the flow as in the right-hand side. I have a lot of slides, but I'm going to start with showing you some examples, and then you might understand it much better than if I just tell you what it's all about. In the examples I'm going to show today, I'm using an open source film database called Sequila that you can download directly from Oracle. You see the URL here. So I'm going to use JShell to show you this. And how many of you guys have used JShell? Not that many. Okay, it's a read, evaluate, and print loop. So you can write an expression and then it prints and you can write stuff again. It's nice because you don't have to launch your IDE to test things. So here I have my test project, and there is a special file called JS, which starts my JShell. So I'm going to start it right now. So there we go. I'm running Java 10 in this example, and JShell is very cool in the way that you can just write an expression here. For example, 1 plus 1, and that is unsurprisingly 2. And you also notice, if you can see that, you can notice it's called $1, which is an anonymous variable, because I didn't assign this expression to any variable. So I can use this $1 now in further computations. I can also create objects like this. List of 1, 2, 3, 4, 5. This will create, of course, a list. This is a new feature since Java 9. So there I got my list, and it's stored in a variable called $2. So now I can use $2, for example, and write size, which will, of course, return 5, because there are 5 elements in my list. 1, 2, 3, 4, 5. There's also another way. I can, instead of executing the size directly, I can use stream. So, and then I can use count. And then I have counted all elements in the stream. And of course, this is still 5, because otherwise it would be very peculiar. And if you look at the first example with size, that will go directly to the list and retrieve the size. Whereas in the second example, we'll actually materialize and iterate over every element and then count them. So the complexity of the first example is 1, and the complexity of the second is called to be ordo n, which means that the more elements you have, the more time it will take. So why would we ever want to use streams if it's not as good as size? Yeah, the reason is, of course, that a stream is much more useful. So, for example, if I want to count every element that is even, I can filter out those elements like this. Filter, and I write an expression here which holds true, and then all those elements will pass the filter. So if I have an integer I, then that integer divided modulo 2 should be equal to 0. So that is all my even elements, and it gives me back 2, and that is correct because you can see here that 2 and 4 is even. And of course, if I don't only want to count, then I can collect them in another list, like this. I can write collectors to list, like this. There we go. So now I have a sublist, basically, of the even elements. And this is nothing new. This has been around since Java 8. But the new thing here is that I want to use streams to work with database content. So that is new, and that is why we created Speedment. So I'm going to import let me just open some imports that I need to run this as a stream. So what this does is it adds some classes. The classes I've added now are generated automatically by Speedment, and there is one class for each table and some other classes. So this allows me to do streaming, and now I'm going to use, let me use Java 10 so I can use var. Have you used local variable type inference? Anyone here? No one. And Java 10 is already out. Okay, instead of writing the particular type, Java can now infer your type for you. So I'm going to use that, and I create an application like this. This is just a method with a few commands within it, a convenience method. So now I've started Speedment. And Speedment allows me to stream towards a database instead of just regular Java collections. So, and Speedment works with something called managers. So now I can create a manager called films, which of course represents all the films in the database. And I retrieve that now. Film manager class. So that's my manager. So now I have films, and now I can use films just as I used my list before. So for examples, I can create a stream over all the film elements and then count them like this. Okay. So let's stop there. What happens? Well, I create a stream, I count all the elements in the stream, all the films, and apparently there are 1,000 films in this particular database. And there's something in the middle, and that is actually how the manager compiled this to a SQL query under the hood. So I never write SQL. Speedment is capable of automatically deriving what the SQL command should be when it looks at the stream. So it selects count all the elements from the film table there. And this is very cool because this is not an order n operation. This is the order 1 operation because the stream only retrieves a single value from the database. So it doesn't have to iterate over all the films. So that's cool. But we can do cooler things than that. So we might want to count maybe films that just that are short, for example. And what is short? Let's try and see what that can be. I want to filter out just a couple of films, and then I can type films, film, dot, and then I can use completion here to see what columns I have. So maybe duration looks good, or not really. Length, less than 60 minutes. So now count all the films that are less than 60 minutes, with a length of less than 60 minutes. So now we can see it's a more complicated SQL query there. And you can see at the end that the 60 is there. Let me try this. Oh, can't see this, but there is a 60 there. So the entire stream is collapsed to a SQL query and sent to the database, and then all those films are counted again in a single operation. And that is cool. And instead of counting the different films, you might want to categorize them. So you can do that using standard streams, and then you use collect, grouping by. And then I tell Java what I want to group on, and that is also film. Maybe rating, maybe you're familiar with the rating system here in the US. They rate films if a kid should see it, or if a grown-up can see it, and so on. So I want to apply the rating getter, and then I want to count those elements. So what it does now is that it retrieves all the films that are short, and then they categorize them depending on the rating. So you can see the category G 21 films, PG 22, NC7 21, and so on. So this shows that you can use all the semantics that are built into streams seamlessly with Speedment. So what this does, was able to compile all the way up to the collector, but the collection was done in Java, in the JVM. But you don't see that. So that's cool. Well, what if the database is huge? What if you have millions or billions or even trillion objects in your database? And then, of course, it gets slow. So then there is another solution. Instead of using a database, you can use an in-memory store and retrieve your data in an even faster way. I'm going to just show you this briefly. So then you have to build your application a little bit different, but the semantics is exactly the same. So let me do this. Create, well, so I'm building a new kind of Speedment, and in this case it's an enterprise version. This is not open source. And then I have to create the snapshot. So I'm going to do that right now. So I'm going to retrieve a component called data store. And then I'm going to call load on that component, which didn't work. Okay. Let me start from the beginning. So I import my imports. Start my application, and let's see if it works this time. Get or throw data store component. And this time it works. So now I'm creating a complete snapshot of the database in memory and off heap. That means that I can have a lot of objects there. If you're using on heap, then you're limited by garbage collection issues. And then I can do exactly as I did before. So film manager, films, film manager class. So here I have my films stream count, for example. And now this is much faster, and you didn't see any SQL query, so now it goes into off-heap memory and retrieves all the elements from there. And this makes it perhaps 10 or thousands or hundreds of thousands of times quicker, depending on your application. Okay, so let us exit here. So everything now is built into my POM file. Do you use Maven for your projects? Anyone uses Maven? Oh, that's the record in raised hands for today. So you just add basically 2 sections to your POM file. You need a plugin to generate the code, and then you need a runtime. I'm going to show you more about that later. You can also, of course, get Speedment very easily. Let me show that. You go to GitHub, and then you have a lot of resources there. You can read exactly all the examples. Basically, I showed today. There is a basic tutorial and a lot of stuff, resources, how you configure your POM file. And on the home page, there is something called a configurator, an initializer that allows you to automatically do your POM files. So maybe I need Oracle database and I want to use the Spring plugin. And then I can see my POM file exactly and just cut and paste into my application, and also see an exemplary main file here to start your application. So it's very easy to use. Okay, so let's get back. So that was the demo. So, of course, if you compare SQL and stream operation, they are kind of similar. So in the first example, it's a SQL query saying that we want all fields to the rating PG13. And in the second, we say the same, basically in the stream, saying that we have a stream where we filter out all the rows having a rating equal to PG13. So it's very similar in that case. And of course, if you look at all the SQL commands, or almost all SQL commands, there is a corresponding stream operation to that too, and they are very similar. So for example, count is count, limit is limit, distinct is distinct, and there are some others like where is called filter instead, but it's basically the same thing. So it's very easy if you know SQL to write a stream. So why did we develop Speedment? We realized that it takes a long time to write an application with a database. It was a lot of boilerplate coding. And you have to mix SQL and Java, and even though it's just maybe not exactly SQL, it's something similar to SQL. And it was slow. So we created Speedment, and we use pure Java from the entire application, and everything is type safe. And the streams are lazy, meaning that you only retrieve the elements you need in a stream, not all of them. And everything is licensed on Apache 2, so you can create your own variants of Speedment, use it in your products, or change it and do whatever you like with it. And we become, in 2017, the third most popular ORM on GitHub. Speedment is used everywhere in the world, in particular in the US, Germany, and China. But pretty much everywhere. And how does it work? It connects seamlessly to the database. It pulls in data as streams are consumed. And streams, they introspect their own pipeline before they start. And that is how operations like filter and sorted can be moved into the stream's pipeline and merged into the SQL query. So let us take a closer look at SQL versus streams. They have another similarity. They are both declarative. And what do we mean with declarative? Well, declarative means that we're showing what we want and not how we want it. And that is most easily understood if you look at the SQL query there. It says select star from film where rating equals PG13. But it doesn't say how the database shall do this. It doesn't say the database is free to do this in any way it wants. For example, by iterating over all films and evaluating the filter, or more likely using an index, so it can retrieve all those films directly from an index without iterating over unnecessary items. And the same is true for streams, actually, because if you look at it, the first row says film.stream says I want a stream that when it's consumed contains all films. And the next row says I want to modify this stream, so when it's consumed, it only contains those filters matching this predicate. Below the ratings is PG13. It doesn't say that it shall iterate over all the films, and this is a mistake many people do. So we can replace a stream with a new stream implementation that only produces that particular set of films. Another thing is that when you're using SQL, you have to worry a lot about how things are coded. In Java, this is crystal clear. The film rating should be exactly equal to PG13, not PG with a small g or P with a small p or something like that. And if you want to emulate that in SQL, you have to add stuff, because by default, it's case insensitive in most cases. So, and of course, you only want to retrieve those columns that is a part of your domain model. So you need to write even more code. And if you just add something sorted, in this case we apply a comparator, then your SQL code is going to be even bigger, and you have to worry about is the order null sensitive? Do I want to have nulls first or nulls last, or things like that? In Java it's clear, and this is only the stream, but then you have to write all the boilerplate code around. Do you recognize this code snippet here? How many of you have written that before or something similar? Well, that's a lot of people. So you don't want to do this over and over again. Okay, so let's talk about lazy evaluation. In this case, we only want to see 10 films. So we put a limit of 10, and then when this is executed, only 10 films are retrieved from the database. And that is good because in some other solution, everything is pulled into a list, and then you consume the list. But that doesn't help you so much because then you have populated your entire list. Maybe you have 1,000 items in a list, but only need 10. So that's a waste of resources. Another cool thing with Speedment is that it supports parallel execution out of the box. So there is a notion in streams that you write .parallel, and then everything is executed in parallel. And depending on how many threads you have on your server, you receive that many -1, or in some cases that many threads that consumes your stream entities. And this works automatically and gives you a way to consume things from a database in parallel, which previously was very difficult to do, if not impossible. And it's very easy. So, of course, you can write your own parallel executable JDBC. I did that, but I can tell you, it's not easy. Okay, so let's check another example. This is similar to the example we had before. We have two filters. One rating equals PG-13 and another now film length greater than 725. So how does Speedment treat this stream? Well, first of all, the stream is an interface, which is a standard interface in Java. So we haven't invented this API. It's a standard Java stream. But the implementation of the interface is different than, for example, for a list. We have full type safety, so you couldn't write another enum type here. And only one value is loaded from the DB, as I told you before. So that's cool. So, and also they are rendered differently depending on what kind of database you have. So for example, on the right-hand side here, you have MySQL, whereas here we have Postgres. And if you have maybe Oracle or some other database, that query will be rendered depending on that database type. And you don't have to worry about that. You can just switch database and it will be rendered to that database type. So let's check the database pipeline, or the stream pipeline, sorry. So from the beginning we have the source, which is default to everything. We have a filter, and we have another filter, and then we have a terminating operator. So before the stream starts, it checks its own pipeline, and in this case it will see that if I replace the source with this, I can actually remove this filter. So that is actually what is happening. And it continues and see, wow, if I replace the source, I can also replace this other filter. And then it checks the terminating operator and see, I can update my source and make it even simpler. So now we have collapsed the entire pipeline to a single operation. Is this really legit? Can we do this? Can we manipulate streams like this? The answer is yes. This is something that was predicted by the designers of the stream interface from the beginning. So if we look at the Java docs, for example, for Per-Ake, which just looks at the element in a stream, it says, in case where a stream implementation is able to optimize away the production of some or all elements, such as first, find first, or count, the action will not be invoked for those elements. So this is really anticipated. Coming to the code generation, Spearmint will generate Java interfaces for all entities. So you can overload and override those with your own implementation, or can you use a default one. Also, the managers are interfaces, so you can modify the behavior if you want to do that, or you can use the standard ones. Initializing Speedment was something I didn't show in my example, but basically this build application was these 3 lines, because Speedment retains all the metadata in something called an application builder, which is generated automatically, but it doesn't store, for obvious reason, the password, because that is sensitive, so you have to do that yourself. And then you build your application, and then you can retrieve the managers, which are in turn used for retrieving data as streams. So the classes are generated automatically. and the builders are configured automatically and generated automatically, and the managers are also generated for every database table. So many people use Springs these days, so if you want to configure Speedment under Spring, it's very easy. You can create just a configuration, and maybe you will have variables for username, password, and schema, which schema you're using, and then you just bean annotate it, and then you will be able to pick up this bean within Spring very easily. So the same goes for the individual managers. For example, you have a field manager and you retrieve that from the application. And once you have done this, all your logic is a single row. You out-to-wire just your manager in your code, and then you can work with them. So this is a complete example of a REST endpoint service, where you can retrieve fields with a certain rating, and you can select which page you want to be on. For example, page 3. And because in Spring you can return a stream from a method, you can just return a stream of all fields, filter the rating you have said, sort it in a default, in this case a length. Of course, you can send that as a parameter too if you want to have a variable sorting criteria. Skip page times the page size, and then just limit to the page size. And then the REST API is ready. So it's very easy to write REST APIs. And this will be compiled to something like this. Select from film where your condition is set and order by. And actually there is a plugin that you can use that is also open source with Spring. So this plugin will generate all boilerplate annotation and beans for you automatically. So get started with Speedment. Just go there and download it. Use the initializer that I showed before. Here you can select the database you have, what JDBC drive you want, whatever, and you have your POM file and main file generated for you. So basically this is what you need. You need a plugin, a Speedment plugin in Maven. And you need, and that is generate source file based on database. And also you need the runtime, which is a comparatively small jar file. And it doesn't have any dependencies. So you will not run into the jar hell. So it doesn't depend on Guava, for example, or JSON or something, JSON or something other. You can just use it without interfering with your other project components. This is how it looks. First time you start, you get this kind of dialog that you can point to your database, select which type you have, port, and give credentials, and just click connect, and then on the right-hand side, you see your database metadata, and you can click there. Maybe you want to disable some tables and columns that you don't want in your model, and then just hit generate at the top, and it will generate all code for you. So the way you use it is you generate code, you write your logic, you run your application, and if you update the database, you go back again. And of course, there are Maven targets that can do this automatically if you don't want to use a GUI. So in summary, Speedment converts streams to SQL automatically. It is type safe as opposed to SQL. It creates lazy streams so that you only have to pull in what you need. And it allows you to use parallel streams in a very easy way. Of course, you can use it with almost any data source, all the common database types that are out there. You can use it with binary or CSV files, Avro files, or you can plug in your own readers. One guy did Google Sheets, so he can use Google Sheets as a data source. You can deploy anywhere, especially with Java 10. It's very good to use Docker and Kubernetes. Or you can deploy in any cloud service out there. It integrates well with all the 3 big IDEs. Most people use IntelliJ these days, but you can use it if you have, like I do, use NetBeans or Eclipse. You can use any EE server or Spring server. Doesn't prevent you from using other more rare servers either. And you can run it on any Java version from Java 8 to Java 10. In fact, a bit faster on Java 10 for some reason. Maybe it has to do with string handling. So on the enterprise version, it has the same API as the open source, but it's faster. And you will have a query latency sometimes in the nanoseconds, well below 1 microseconds. So it's perfect for low latency application, an application with very high demands. And usually it's 100 to 1,000, maybe 10,000 times faster than using a regular database. And the good thing is that you can keep your database, so you don't have to migrate. You can still have the database as the source of truth, but you still get this speed up in your application. So that was my talk. I'm going to have a talk back to this talk about the acceleration and ultra-low latency. So I'm going to show you a little bit the same streams, but I'm going to show a demo when we use this low latency, ultra-low latency application in practice. And if you want a trial license for enterprise, you can contact me, or if you want to try the open source, just go to GitHub, and I hope you find this interesting. And by that, I open up for questions. Yeah? Yeah? I think I get your question. The question is, when you have all your data in memory, is it actually on the machine you're running your application on? Is that correct? And the answer is yes. That is the only way, and I'm going to explain why in my next talk very carefully, so you're welcome there. But that is the only way to get ultra-low latency. And by ultra-low latency, I mean 200 nanoseconds or 300 nanoseconds. So the answer is yes. And of course, you need a lot of RAM. But there are some ways to mitigate that demand, which I'm also going to tell you in the next talk. That's a great question for raising the interest for my next talk. That's good. Yeah, so the question is, how do we convert things like strings, for example, which may differ from different database types into Java? Is that correct?
Well, a lot of that has to be done at runtime, but in the case of the in-memory database, are you already converting everything natively to be already ready to go in Java?
Okay. Question is, when we store everything in memory, do we do the conversion a priori, or do we do it when we use it? And the question is that we do it when we pull in data. So we convert it, and actually you have the ability to apply something called a type mapper on all the columns. So you can use one of the maybe 25 built-in converters, or you can write your own. So you can, for example, convert a string to an enum or something type you have written yourself, if you have maybe a low cardinality column or something, or if you have a very particular type of column, you can write that and map that to something more efficient. So the answer is that. Good. Corina, do we have like traits for people who ask questions? Yeah. So everyone who asks a reasonable question get this trait from Corina. Treat. Oh, more questions? Yeah.
So when you wrote the database in memory, are you taking care of deletes and kind of modifications and all those things, or is it like a one-time thing? How does that work?
Question is this a one-time operation, loading everything into memory, or how is that handled? Is that correct? So the thing is that Speedment is working with something called snapshots. So first time you start the first snapshot, and then after a while you can take another snapshot, maybe after 5 minutes or after 1 day or whatever, and then you can continue work with that snapshot. So you can have several snapshots in memory simultaneously, and you can and there's also a reusability between the snapshots. So if you do not change so much, then of course you don't have to create a completely new snapshot. But this is also something I'm going to talk about in the next talk. Yeah. Okay, more questions? Yeah? I don't see the hand. Oh, there. Okay, question is, how do we do with updates? And the answer is yes, you can update. As any ORM, there are, of course, methods to update a database. And the cool thing is that you can do that in streams too. So you can create a stream that updates a lot of elements and then applies an updater. For each element applies an updater, and that will update all the entities in that stream, for example. So yes, we can do that. More questions? No question? No? Okay, yeah, good.
Just a flat representation of the, like, so you can map only like one table to one stream, or you can combine like multiple entities.
Good questions. Can we combine multiple entities into one stream? Is that correct? I have to say yes and no. In a week or so you can do that, because the new version will have joins. So you can actually set up a relation between one or several columns, and then you can create a stream that contains entities, kind of tuples with entities, and then you can work with them. And you can do that today also by applying a mapper. You can apply a flat map, which is basically equivalent to a join, but the join feature will be much more efficient. So that will come in the next version called 3.1. Okay. Okay, thank you very much. Thanks for your interest.